Java is a set of computer software and specifications developed by Sun Microsystems, later acquired by Oracle Corporation, that provides a system for developing application software and deploying it in a cross-platform computing environment. Java is used in a wide variety of computing platforms, from embedded devices and mobile phones to enterprise servers and supercomputers. While less common, Java applets run in secure, sandboxed environments to provide many features of native applications and can be embedded in HTML pages. Writing in the Java programming language is the primary way to produce code that will be deployed as bytecode in a Java virtual machine. Bytecode compilers are also available for other languages, including Ada, JavaScript, Python, and Ruby. In addition, several languages have been designed to run natively on the JVM, including Scala, Clojure and Groovy. Java syntax borrows heavily from C and C++, but object-oriented features are modeled after Smalltalk and Objective-C. Java eschews certain low-level constructs such as pointers and has a very simple memory model where every object is allocated on the heap and all variables of object types are references. Memory management is handled through integrated automatic garbage collection performed by the JVM. On November 13, 2006, Sun Microsystems made the bulk of its implementation of Java available under the new General Public License. The latest version is Java 8, the only supported version in 2015. Platform. The Java platform is a suite of programs that facilitate developing and running programs written in the Java programming language. The platform is not specific to any one processor or operating system. Rather, an execution engine and a compiler with a set of libraries are implemented for various hardware and operating systems so that Java programs can run identically on all of them. There are multiple platforms, each targeting a different class of devices. Java Card, a technology that allows small Java-based applications to be run securely on smart cards and similar small memory devices. Java specifies several different sets of libraries for devices with limited storage, display, and power capacities, often used to develop applications for mobile devices, PDAs, TV set-top boxes, and printers. Java SHA, for general-purpose use on desktop PCs, servers and similar devices. Java EE, Java SHA plus various APIs useful for multi-tier client-server enterprise applications. The Java platform consists of several programs, each of which provides a portion of its overall capabilities. For example, the Java compiler, which converts Java source code into Java bytecode, is provided as part of the Java development kit. The Java runtime environment, complementing the JVM with a just-in-time compiler, converts intermediate bytecode into native machine code on the fly. An extensive set of libraries are also part of the Java platform. The essential components in the platform are the Java language compiler, the libraries, and the runtime environment in which Java intermediate bytecode executes according to the rules laid out in the virtual machine specification. Java Virtual Machine. The heart of the Java platform is the concept of a virtual machine that executes Java bytecode programs. This bytecode is the same no matter what hardware or operating system the program is running under. There is a JIT compiler within the Java Virtual Machine, or JVM. The JIT compiler translates the Java bytecode into native processor instructions at runtime and caches the native code in memory during execution. The use of bytecode as an intermediate language permits Java programs to run on any platform that has a virtual machine available. The use of a JIT compiler means that Java applications, after a short delay during loading and once they have warmed up by being all or mostly JIT compiled, tend to run about as fast as native programs. Since JRE version 1.2, Sun's JVM implementation has included a just-in-time compiler instead of an interpreter. Although Java programs are cross-platform or platform-independent, the code of the Java virtual machines that execute these programs is not. Every supported operating platform has its own JVM class libraries. In most modern operating systems, a large body of reusable code is provided to simplify the programmer's job. This code is typically provided as a set of dynamically loadable libraries that applications can call at runtime. Because the Java platform is not dependent on any specific operating system, applications cannot rely on any of the pre-existing OS libraries. Instead, the Java platform provides a comprehensive set of its own standard class libraries containing much of the same reusable functions commonly found in modern operating systems. Most of the system library is also written in Java. For instance, Swing library paints the user interface and handles the events itself, eliminating many subtle differences between how different platforms handle even similar components. The Java class libraries serve three purposes within the Java platform. First, like other standard code libraries, the Java libraries provide the programmer a well-known set of functions to perform common tasks, such as maintaining lists of items or performing complex string parsing. Second, the class libraries provide an abstract interface to tasks that would normally depend heavily on the hardware and operating system. Tasks such as network access and file access are often heavily intertwined with the distinctive implementations of each platform. The Java.NET and Java.io libraries implement an abstraction layer in native OS code, then provide a standard interface for the Java applications to perform those tasks. Finally, when some underlying platform does not support all of the features a Java application expects, the class libraries work to gracefully handle the absent components, either by emulation to provide a substitute, or at least by providing a consistent way to check for the presence of a specific feature. Languages. The word Java alone usually refers to Java programming language that was designed for use with the Java platform. Programming languages are typically outside of the scope of the phrase platform. Although the Java programming language was listed as a core part of the Java platform before Java 7, the language and runtime were therefore commonly considered a single unit. However, an effort was made with the Java 7 specification to more clearly treat the Java language and the Java virtual machine as separate entities, so that they are no longer considered a single unit. Third parties have produced many compilers or interpreters that target the JVM. Some of these are for existing languages, while others are for extensions to the Java language. These include Beanshell, a lightweight scripting language for Java; Clojure, a dialect of the Lisp programming language; Groovy, a dynamic language with features similar to those of Python, Ruby, Perl, and Smalltalk; Jubby, a Ruby interpreter; Jython, a Python interpreter; Kotlin, an industrial programming language for JVM with full Java interoperability; Rhino, a JavaScript interpreter; Scala, a multi-paradigm programming language designed as a better Java; Gazoo, a general-purpose Java virtual machine-based programming language released under the Apache License 2.0. Similar platforms. The successor Java and its write once, run anywhere concept has led to other similar efforts, notably the .NET framework, appearing since 2002, which incorporates many of the successful aspects of Java. .NET in its complete form is currently only fully available on Windows platforms, whereas Java is fully available on many platforms. .NET was built from the ground up to support multiple programming languages, while the Java platform was initially built to support only the Java language, although many other languages have been made for JVM since. .NET includes a Java-like language called Visual J# that is incompatible with the Java specification. and the associated class library mostly dates to the old JDK 1.1 version of the language. For these reasons, it is more a transitional language to switch from Java to the .NET platform, than a first-class .NET language. Visual JHash was discontinued with the release of Microsoft Visual Studio 2008. The existing version shipping with Visual Studio 2005 will be supported until 2015 as per the product lifecycle strategy. Java Development Kit. The Java Development Kit is a Sun product aimed at Java developers. Since the introduction of Java, it has been by far the most widely used Java software development kit. It contains a Java compiler, a full copy of the Java runtime environment, and many other important development tools. History. The Java platform and language began as an internal project at Sun Microsystems in December 1990, providing an alternative to the C++, programming languages. Engineer Patrick Norton had become increasingly frustrated with the state of Sun's C++ and C application programming interfaces and tools. While considering moving to Next, Norton was offered a chance to work on new technology, and thus the Stealth project started. The Stealth project was soon renamed to the Green Project, with James Gosling and Mike Sheridan joining Norton. Together with other engineers, they began work in a small office on Sand Hill Road in Menlo Park, California. They aimed to develop new technology for programming next-generation smart appliances, which Sun expected to offer major new opportunities. The team originally considered using C++, but rejected it, for several reasons. Because they were developing an embedded system with limited resources. They decided that C++ needed too much memory and that its complexity led to developer errors. The language's lack of garbage collection meant that programmers had to manually manage system memory, a challenging and error-prone task. The team also worried about the C++ language's lack of portable facilities for security, distributed programming, and threading. Finally, they wanted a platform that would port easily to all types of devices. Bill Joy had envisioned a new language combining Mesa and C. In a paper called Further, he proposed to Sun that its engineers should produce an object-oriented environment based on C++. Initially, Gosling attempted to modify and extend C++, but soon abandoned that in favor of creating a new language, which he called Oak, after the tree that stood just outside his office. By the summer of 1992, the team could demonstrate portions of the new platform, including the Green OS, the Oak language, the libraries, and the hardware. Their first demonstration, on September 3, 1992, focused on building a personal digital assistant device named Star 7 that had a graphical interface and a smart agent called Duke to assist the user. In November of that year, the Green Project was spun off to become First Person, a wholly owned subsidiary of Sun Microsystems, and the team relocated to Palo Alto, California. The First Person team had an interest in building highly interactive devices, and when Time Warner issued a request for proposal for a set-top box, First Person changed their target and responded with a proposal for a set-top box platform. However, the cable industry felt that their platform gave too much control to the user. First Person lost their bid to SGI. An additional deal with the 3D Oak company for a set-top box also failed to materialize. Unable to generate interest within the television industry, the company was rolled back into Sun. Java meets the web in June and July 1994 after 3 days of brainstorming with John Gage, Gosling, Joy, Norton, Wayne Rosing, and Eric Schmidt. The team retargeted the platform for the World Wide Web. They felt that with the advent of graphical web browsers like Mosaic, the Internet could evolve into the same highly interactive medium that they had envisioned for cable TV. As a prototype, Norton wrote a small browser web runner, renamed Hot Java in 1995. In 1994, Sun renamed the Oak language as Java after a trademark search revealed that Oak technology used the name Oak. Although Java 1.0a became available for download in 1994, the first public release of Java 1.0a2 with the Hot Java browser, came on May 23, 1995, announced by Gage at the Sun World Conference. Accompanying Gage's announcement, Mark Andreessen, Executive Vice President of Netscape Communications Corporation, unexpectedly announced that Netscape browsers would include Java support. On January 9, 1996, Sun Microsystems formed the JavaSoft Group to develop the technology. Version history: the Java language has undergone several changes since the release of JDK 1.0 on January 23, 1996, as well as numerous additions of classes and packages to the standard library. Since J2SE 1.4, the Java community process has governed the evolution of the Java language. The JCP uses Java specification requests to propose and specify additions and changes to the Java platform. The Java language specification specifies the language. Changes to the JLS are managed under JSR 901. Sun released JDK 1.1 on February 19, 1997. Major additions included an extensive retooling of the AWT event model, inner classes added to the language, Java Beans and JDBC. J2SE 1.2 Codename Playground. This and subsequent releases through J2SE 5.0 were rebranded Java 2, and the version name of J2SE replaced JDK to distinguish the base platform from J2E and J2ME. Major additions included Reflection, a collections framework, Java IDL, and the integration of the Swing graphical API into the core classes. A Java plugin was released, and Sun's Jvm was equipped with a JIT compiler for the first time. J2SE 1.3 Codename Kestrel. Notable changes included the bundling of the hotspot Jvm, Java Sound, Java naming and directory interface, and Java platform debugger architecture. J2SE 1.4 Codename Merlin. This became the first release of the Java platform developed under the Java community process as JSR 59. Major changes included regular expressions modeled after Perl, exception chaining, an integrated XML parser and XSLT processor, and Java Web Start. J2SE 5.0 Codename Tiger. Originally numbered 1.5, which is still used as the internal version number. Developed under JSR 176, Tiger added several significant new language features including the for each loop, generics, autoboxing and VAR args. Java SHA-6 Codename Mustang. Bundled with a database manager and facilitates the use of scripting languages with the JVM. As of this version, Sun replaced the name of J2SE with Java SHA and dropped the 0 from the version number. Other major changes include support for pluggable annotations, many GUI improvements, including native UI enhancements to support the look and feel of Windows Vista, and improvements to the Java platform debugger architecture and JVM tool interface for better monitoring and troubleshooting. Java SHA-7 Codename Dolphin. This version developed under JSR 336. It added many small language changes including strings in switch try with resources and type inference for generic instance creation. The JVM was extended with support for dynamic languages, while the class library was extended among others with a join, fork framework, an improved new file I/O library and support for new network protocols such as SCTP. Java 7 Update 76 was released in January 2015, with expiration date April 14, 2015. The current update version, Java 8. Notable changes include language-level support for Lambda expressions and default methods, the Project Nashorn JavaScript runtime, a new date and time API inspired by Joda time, and the removal of permgen. This version is not officially supported on the Windows XP platform. However, due to the end of Java 7's lifecycle, it is the recommended version for XP users. Previously, only an unofficial manual installation method had been described for Windows XP SP3. It refers to JDK 8, the developing platform for Java that also includes a fully functioning Java runtime environment. In addition to language changes, significant changes have been made to the Jvm class library over the years, which has grown from a few hundred classes in JDK 1.0 to over 3,000 in J2SE 5.0. Entire new APIs, such as Swing and Java 2D, have evolved, and many of the original JDK 1.0 classes and methods have been deprecated.